there's my handle up there. So if you go to YouTube, you just said hi. It's recording you right now. So okay, so here's our lecture for today. We're doing P4, which is polynomials. Our objectives were to understand the vocabulary of polynomials, add, subtract polynomials, multiply polynomials, all these things I think we remember from second year algebra. Use the FOIL method. We'll talk about that. Special products like conjugates and perfect squares and all that good stuff. And then perform operations within several variables. All right. This is the definition of a polynomial. And I always looked at it like, man, that's just a lot of gibberish. Yeah? You like a lot of gibberish? I want to start by talking about this term right here. It says a sub 1 x. And it's really just a pattern that continues over and over and over and over, right? When we go back and we think about polynomials, they usually follow this order. Let's start with maybe like, I don't know, 3x squared plus x minus 5. They always follow that order, didn't they? Yeah, the biggest one at the front, and they kind of work their way down. That's exactly what this definition is saying. Not as cleanly, but that's what it's saying. So when we look at this piece right here, that's this part right there. It has a coefficient. In this case, what's the coefficient of x? 1. They're calling that coefficient a1. Whatever that coefficient is, that first coefficient, hence a sub 1. And then they have x, and it's technically to the first power. But do we need to take x to the first power? No. It's one of those things that's just understood. Make sense? And then we have, over here we have plus a sub 0. And it's because it follows a pattern, because it does have a sub 0, x to the 0 power. But what is x to the 0 power? 1. And anything times 1, we just talked about this, itself. So therefore, it would just not make sense to multiply by a 1, and that's why it doesn't show up in the form. It makes sense, right? Yeah. And that's why we don't have this here. But again, if we follow our patterns, then we would have the next value, which would be a sub 2 x to the second, right? So it goes x to the 0, x to the first, x to the second. The next one would be, yay, patterns, a to the third, x to the third. So that, what you're looking at here is the entire right side of that definition of a polynomial. Well, let's take a look at the other side. Let's take a look at the other side now. I'll switch colors here to the red. So I'm looking at this side. What's the biggest polynomial you've seen? Degree. X to the second. This is the highest one? Second. Anybody seen cube functions? To the third. Yeah. Anybody seen coordinates? To the fourth. Oh yeah. Right? Can we have a fifth degree polynomial? Yeah. 6, 7? How high could we go? We could go for it after. Hence, this is saying, hey, you know what? That's going to be a sub n, x to the n, where n is the biggest value of your specific polynomial. Let's say mine, for some reason, was 3x to the 12th, okay? The question is, how do I get the next one to the right? I would have to add something to that, right? Well, if on this side, on the left side, we were increasing by 1, once we hit the top, what should we do to the value then? We subtract 1. That's why it is, oops, the coefficient n minus 1 and x to the n minus 1 power. Because it's now decreasing on this side. And that's why there's these ellipses in the middle, dot, 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 because that kind of just joins the two together. Does that part make sense? Yeah. So it's just kind of bleh, but that's the definition. Okay? Questions on any of that? Cool beans. All right. When a polynomial is written in standard form, that means that you're writing it in descending powers of the variable. Descending. That means from the biggest power to the smallest power. Okay? Okay, monomial, binomial, trinomial. Monomial has one term in it. So here is m. M is a monomial. But if I add a 2 to m, now it's still a monomial. Now it's still a monomial because it's just one term. I don't know what this number is until I know what m is. But once I know what m is, I can tell you what number that is. Make sense? So it's still a monomial. And we can put, and we can make it 32, still a monomial. Remember, just one term, one specific value. Once we add something else to it, now it's a binomial. You've got two different numbers that you're working with here, and you're trying to add those. But you got your binomials, and of course, if it's 3, then it's a trinomial. Questions on that? Okay. If you get something after that, just call it a polynomial. Right? Poly means many. They say 3's a crowd, so after that, it's just 2. Alright? Cool beans. Like terms. Keyword. Exactly. You have to have exactly the same variables. I keep wanting to grab the black. 3x plus 3x to the second. I think I might have used that already. They both have 3, they both have x. But you still can't combine them? Why? Because one has an x squared. Does that even matter? Does that make a difference? Why does it make a difference? Huh? They're not the same value? What's not the same value? Yeah. Once I figure out, let's say x was 4, then that would be 4 here, right? But over here, that's not 4, that's 16. Makes a world of difference, doesn't it? So don't combine those because here you're asking for 3 4s, while over here you're asking for 3 16s. So therefore you can't combine them. You will not get the value that you're looking for. Whoa. Perform the indicated operations and simplify. I like the old school math. If you're the person that likes to do this bit, more power to you. Okay? Fine. But I like to do things the way that I was taught from before, and I'm going to stack them up like I used to before, because I really like the place value stuff that I was taught. So when I combine these, I've got negative 20, what is this, 8, negative? 8x, that's going to be just x squared. I could put the 1, but I don't need to. And then I've got negative x cubed. That stacking business really helps when you're multiplying polynomials. And everything lines up really nice. And at the end, you can just add down the columns. It might be a little tedious if you're just doing addition, subtraction. But I'm telling you, when you do multiplication, it's really nice that all those place values just line up. Okay? Cool. Product of 2 or more monomials obtained by using the property of exponents. We use the distributive property to multiply monomials. We know that. Multiply 2 polynomials when neither is a monomial. Just show me. Okay, so here, a perfect example. I want to take 3x squared minus 5x plus 4, and I'm multiplying that by 5x minus 2. And we're multiplying. I'm not going to use x because I don't want to confuse myself. But remember how we used to do this back then? Yeah, you start with the first value, don't you? I go with this, and I multiply to every term. So in this case, I'm going to have negative 8. That'll be a positive 10x. And then I'll have a 6x squared. Then I'd go to the next part. I'd have to put in a 0 for place value. You remember that? Or an x or a blank, whatever it is that you do. What's up? You are correct. Negative 6. Thank you. And then I can continue with the other multiplications. So 5 times 4 is 20x. Oh, look at that. They lined up. Negative 25x squared. Look at my x squares lined up. Then I've got, what is that, 15? 15x cubed. That's cleaner to add up, isn't it? Then when we do that whole FOIL bit and they're everywhere all over the place and you miss one, we don't want to do that. So here we go. I think I got them all. Okay? Questions there? Yeah, it's also immortalized on YouTube for you to go back I'm just kidding. It's right here.
I thought you were going to point at the fan for a second. I was like...
Yes. I used to love doing that as a kid.
I cut my lip doing that.
Do all the robot. Did you?
I have a scar.
Oh. When I lived in Missouri, they would put fans on the windows. Did anybody ever see that?
Yes.
Because what they would do is they would suck the heat out. So the fans were in reverse. But there are these massive ones with the motors, and everything was exposed, the fans and all. And my brother and I used to put our fingers in there on the fan belt, so that, yeah, it was kind of a game. And every once in a while, your finger would go through the loop, like, oh, bleeding and swollen. It was fun. You know, guys are always trying to be who's tougher, or who can get the closest without getting, hit or whatever. Yeah, it didn't work. All right, let's move on here. Yeah, guys, we got a bunch of weird games. Like, we're trying to be macho. It's like, and then you go home, you're like, what was I thinking? All right, FOIL method. You guys have all heard of FOIL. It just turns out that that's the way it is. But what you're really just doing is using the distributive property twice. So here's what's going on. I'm going to start with this value, and I'm going to distribute it. 7 times 4 is 28, x squared. And then I'm going to multiply here. That is a negative 21x. I'm done. Therefore, I go on to the next value. And guess what I'm going to do? I'm going to distribute it. That's going to give me a negative 20x plus 15. And then when I combine them, I've got 28x squared minus 41x plus 15. So all I really did was FOIL twice. But it turns out that that's the order that FOIL works in. So whoever invented FOIL got credit for something really lazy that we all did anyway. Like, I want to be that guy that finds somebody, just name something obvious. Like, oh yeah, use your Windows method. I gotta find something. Just FOIL and just distributive property twice, right? You cool with that?
Wait. How much does that cost you?
Oh, my hydro flask?
Yeah.
Like, big. It was like, no, like 60 something. It's like $1 an ounce at the end. Yeah, once you get to a certain size, that's what it can turn out to be, like $1 an ounce. The smaller ones, I don't think they're worth that. You don't get your money's worth, in my opinion.
I got some sales for like $18.
Oh, that's awesome. Whenever you see that, let me know.
Really good sales on hydro. Yeah.
Well, now I'm upset because the new ones come with a boot. Have you seen the boot ones?
I know. Yeah. You gotta tell it you're they're like, there's like
Yeah?
stuff that you have to put on the bottom.
That's what I need to do. My little girl wants a hydro, but she leaves all her cups at school. I'm like, I'm not buying one of those.
How many times do you fill that up? Both drink a day.
Just one.
How much was it?
So what is it, 64?
Greg, you don't listen.
I think it looks like those old milk cartons.
It was like 65, 70 package and stuff. It's not bad.
65 for that?
It's half a gallon.
That's how much you're supposed to drink a day anyways.
I just buy 5.
Moving on. We just digressed.
For like $4.
Okay. Okie dokie, artichoke. Here's the special products for you guys. You should have these formulas already. They kind of follow a pattern. But here's your difference of your conjugates. Your conjugates are going to produce difference of squares. So when we do get to factoring and you recognize the difference of squares and you're trying to factor, just go in reverse. You're going to get conjugates. Okay? Over here you've got your perfect square business going on in the middle. Okay, so make sure you have those formulas. They're your skeletors. Skeletons. Your skeletons. That's what the kids and I call the little skeletons in the Minecraft. They're all into the Minecraft. Like, look, look at the skeletors. No, I grew up with He-Man. That's why. Yeah, so when at the assemblies, Mr. Rudd said, "You have the power too." Japan's all like, "No, He-Man has the power." I have the power. You guys have these?
No.
No?
You got class dojo now?
Yeah, I use it all the time. Yeah, your guys' dojo's ready already, so if I ask a question, so my rule is no hands up. If you want to answer something, you gotta pray the dojo calls you.
Wait, what's the dojo?
It's called Class Dojo. What I'll do is I'll hit this random button, and it will pick somebody like Elijah, and Elijah would have to answer the question. And if he says I don't know, I will come back to him. So there is no not answering my questions. Everyone participates. You can't just be a wallflower. What? Do what? I will. That's not going to be a lot. There will be questions I ask. There will be times and you'll be like, and you know what I love about using this? That everyone's going to have the feeling that it's going to be them. And the little clicking is just builds the anxiety. I saw my name. Oh, it's not. They're going to stop.
Like the spinning on a wheel. Playing a game. You think you're gonna get like the jackpot.
Oh.
Like you like get to like 1,000, but it really goes to like you're getting like 4 tickets. I'm like, really?
Not cool. All right, so polynomials with several variables. A polynomial with 2 variables, x and y, contains sum of 1 or more polynomials in the form. And there you go. I think I showed you a few of them before. That's just a polynomial that has a couple different variables. The coefficient is a in this case. And then we have degree. Now this is important to note, because this is pretty obvious, right? The degree here is 4. And I have, let's do 5, because I use 3 and 4 a lot. X to the third, y to the third. These are obviously less than that, right? 3 and 3 is less than 4. Which has the higher degree? This guy does. Because the degree would be the sum of all of the exponents there. So the degree of this bad boy is 6. Okay? So be careful with that. Be careful with that, please. What did that say? Degree polynomial 2 variable. Yeah, what I just said. So multiplying them. So in this case, this is just FOIL, and hopefully you guys, you drilled and you drilled and you drilled and you can do them in your cabeza. It's one thing that I like to do is just drill these things into you, and so that you're doing that FOIL thing in your head, right? So this should just be 21x squared. This should be -7 minus 18, -7 minus 18, -25xy plus 6y squared. Did we not do that? Yeah. What? Oh,
Something about that triangle, like
if you don't see what I did there, don't sweat it. Just multiply it out, people. Just FOIL it out. What is that? 21x squared, 7xy, -18 xy, and then plus 7y squared. So 21x squared.
6y. You don't ask
Oh.
about it.
JK, smiley face. LOL. Yeah, I saw the 7 again. So same thing. But you should really get used to when you're foiling. Practice this. Do the first one in a one step. Do the outside plus the inside, and then finally do your last one. That's why I was able to do that. And that's only going to be able to happen if you gotta have like terms on the binomials type thing. If this was like a B, all bets are off. You can't do that. Okay? But if they're like terms, you can just go and do that first, outside plus inside for the middle, and then do the last one.
That would be your way, right? Like your way.
Or you can stack them.
Isn't that yours?
Yeah.
Well, this is a FOIL problem. The only time I would stack them if they're really long. But FOIL is so much faster.
So for like if they have 2 terms, or like
If it comes to you, let me know. Okay? All right, let's move on because I want to get through this. Boop, 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 boop. There's a FOIL method again. Oh, yay, we're done.
Oh, what was that?
Bye, YouTube.